I think to invent, you fundamentally need to be curious. And I think you just need to be curious about how things work, how the world works, whether it could work another way. I think that that's something really innate in all the inventors I know, is just that curiosity. I grew up in Lexington, right outside of Boston. I was born at the Brigham, which is funny because I work there now also. I think I was a pretty strong student. I always joke I'm the daughter of Indian immigrants, and so when I was growing up, they used to ask me, are you going to be a doctor, an engineer, or an entrepreneur? Those were sort of like my world of options. And so now we kind of joke because I'm all three. The natural world was so interesting. And then later in college, I would take my first human physiology class, and I really fell in love with the human body. One thing I like to tell the students in the lab is just to sort of set their expectations is an experiment never works the first time. And if it works the first time, it'll probably never work again. That sort of gives them the sense that like a really well thought out experiment needs a lot of troubleshooting and tweaking and conceptualization to really get there. And science is probably 90% failure. The aha moments don't happen that often, but when they come, they're well worth it. And so in order to keep the invention process fun in my group, I have the students spend 20% of their time outside of their really hard, important projects doing what we call tinkering, just playing, just to keep it fun. What motivates me to invent ultimately is to try and improve human health with what I think are an amazing set of resources that have been developed for other reasons. So engineers have for a long time been improving microfabrication to be able to make your computers faster. So they pattern circuits on silicon chips, and in order to get more and more circuits on a chip, they've had to improve the equipment to make those circuits smaller and smaller and smaller. And that makes your iPhone work, and it makes your computer faster. And as someone who's trained as a physician, what I see is a lot of tools that other people have helped develop that we can just borrow. So the focus of our group is to use miniaturization tools. These are things like microfabrication and nanotechnology for human health applications. And we're interested in two disease areas. One of them is liver disease, and the other one is cancer. The Synthetic Biomarker Project is a project where we try and do diagnosis of human diseases non-invasively, so without a biopsy or without an MRI machine, and in particular using urine. Our microliver project is being commercialized through a company called Heprogen. And what they do is manufacture the microlivers at scale and then work directly with pharmaceutical companies to test drugs that are under development for drug metabolism. That's how your body clears the drugs. And then whether they're safe, that's drug toxicity. But now we're really interested in getting back to kind of our original vision, which was making little livers that will grow into big livers and replace transplants. Winning the 2014 Lemelson MIT Prize is such an incredible honor. It's really thrilling. I'm so grateful for the recognition for myself, but also for my team of students and former students and collaborators. And so grateful for holding invention up as something that kids can really aspire to in our culture. I'm so glad that they chose a woman. There's not enough of us that are visible, and so I think it's really great for young girls to see that it's a great career, actually.